Good morning. Still several remarks, maybe two shorter videos before I move to straight probes. Working with angle probes, other things, okay? I thought I need to tell something. Okay, so about the cables. 2 cables is not enough, because if you have such a probe, or if you need to do transfer correction, and one cable doesn't connect well, there is noise all over. I worked with such a thing. The connection here is not stable, let's say, yeah? Because of the probe or because of something, okay? Here. And then there are spikes all over. Then you stop, yeah, you can scan, but you see all kinds of things. A lot of noise. That's not a good thing. What will you do then? Stop working and wait for this one to come after 2 months when you order it. So you should have at least, I have in the box 3, and there are more, but still, because you have to work and do the job, so you should have 2 or 3. Now, connector types. There are different connector types in different machines and different probes. I took that from internet, okay? What we have here is Lemo 00, this one. But there are all kinds of other things, and they are also good, okay? So what I mean by that, here we have different cables, huh? Here is the Lemo ending, but that one is Lemo 1, this one, a big Lemo. That one is small Lemo. So when you buy things, you need to be very careful. And here is this one is B and C, some kind of number. And this one is Lemo 1. Now this one is Lemo 1 and this one is Lemo 0, okay? Because when you have to connect to the machine, one to the probe, or one to the machine, one to the probe, you can do whatever, yeah? Because I can put this into the USM Go and I can connect here a different probe to the big Lemo, okay? It works both ways. Yeah, other kinds of cables. So, some message. So, when you buy things, you need to be careful, because I had these probes with strange angle, and I thought that's micro dots, and I bought the cable, and then it came and it doesn't fit, because that's something strange there. Sonatest old probes, but they are still good. So now I have a cable that I cannot use and the probes that I cannot use. So you should buy the things that to check it 9 times and then buy once. Okay, so connector types. There are different kinds of connectors to the machine and to the probes. Now, probe types. About the angle probes, I already showed, but there are also other things. Okay, that's the double and straight, normal, 0 degree. Okay, here with 2 parts. Here we have what's the 5. Frequency 5, okay? Frequency 4, the size, okay? 1. Now, frequency 2.5, okay? And the size. That's already not great, okay? That's good enough. Okay, we have such things. You cannot see anything there, okay? So there is a way to find that out. Okay, what the size is, what the frequency is, but there is nothing in here. But still, you can turn it. Okay, there you put some oil, put a cap in it and turn it, and then you need to check it, all the kinds, and write that down. That's the old one, okay, with one connector. So there are, you can change the head, okay. Yeah, but you need to do a lot of work to check it, okay. Now there are also other kinds of probes. Yeah. Okay, I'll show you now. Okay, okay, that one is like 1 megahertz, okay, big one, and with a different connector to the different machine, okay. Here you just turn it and that's it, okay. So that one is also Olympus 1 megahertz. That one is a big one, angle one, okay, 60 degree, 1 megahertz, okay, 45, that is a block, okay. So there are, okay, and here is the connector, yeah, that's the lemma, and you connect it to where? To this thing, okay. All kinds of ways to connect them. So these are not bad, these are working things, but these are special things, let's say, because these are big, small, and according to the standard we're working from 2 to 5 megahertz, and these are 1, half, and all kinds of old things. Okay, so I just wanted to show you that there are different things, different connectors and different cables. Okay, pause. Now, checking before work. So if you have a, okay, you can have the V1 block. So if you start working somewhere, what you can do is just take your probe, let's say it's 70, and to turn it around, okay, put like this and check, okay, if it shows from where it should be 100, okay, then you can put it on 70 degrees and we check the angle, okay, like this, okay. You put it onto 70 and recheck the angle. Now what you can do also is put your probe near the hole and recheck, can you see it, and in the place that it should be with a ruler, okay. Now another thing you can do is you take your duck block and you just go through the holes with a duck curve and check if you can see the holes near the top black line where it should be, okay. If you don't have them, well, you should, but there are other things to do. I'll switch it on, and yeah, you can have a duck block like this. That's not a standard block, but okay, what you can do is just take some kind of this piece, okay, then what should you measure? You should measure, let's make it 0, okay, this 1362, okay, then the down up here, that's 937, then this thing 360, 357. Sorry for that. Too much talking. 1908. And then what you do, you just take such a block that is calibrated and done on the normal block. But if you have this one, what you do is you just recheck. And what you do is just go here and find this. And is it in the right place? Okay, then you can turn it around like this on the same side and find the hole there. Okay, with the dark settings, because that's a 3mm hole. Okay, that's the, here you go. Yeah, that's the 3mm hole. So it's not done like this, but it's, yeah, it's good enough maybe. So you just, it should go to your dark curve, but of course you need to do transfer correction, because this surface is rough surface, that's not shiny surface like here. Okay, so and but it's maybe similar to your working conditions. Okay, now so you turn it, you find the hole there, you find the hole there, you can find maybe the hole from the bottom there. Okay, and you just check it with this one, yeah, with this one, and not, you do that with this one, all the calibration, but just to recheck at your site you can do with that one. Two holes different, you can get 1, 2, 3, 4 points, and from the second leg more. That's a small one, so that's not perfect, but that's good enough. Okay, if you have such a thing, yeah, a long one with a hole in it, okay, that's also very rough surface. Okay, but what you can do is measure, okay, from the up 3, from down there, that's 4.5. Okay, so that's different already, and it's very narrow and it's very long. Okay, so what you can do is check with your, the first leg will be a problem here, of course, because it's very near the surface and it's in the beginning, you will have problems, but you can recheck with 70 with this second leg. Maybe if you want to play with a fourth leg, with the fifth leg, sixth leg, because it's long. Okay, and what, okay, that's 10, so it's good enough for us to work. That's over 8, we do 8 and more, so we can do this way with the probe, to put it here, to put it here, to put it here, and just recheck, can you find this thing in there? Okay, because it's a strange block, but you can use it also with a, you can use these with a, to do all kinds of testing with a straight probe, to measure the thickness and stuff like that. Okay, and with this one also there is different. Okay, you cannot measure like this because there are holes, but you can, because you will put it here and the hole is there, so the indication will be like 15 centimeters down there. It's not a bad thing to have. Okay, and then this is a different thickness, this is a different thickness, these are different surfaces, shiny one, and yeah, a good thing. So just what you have, okay, you can recheck what you have calibrated the way it should be with such a thing or such a thing, and if you can find a hole there, 3mm hole, that's your standard defect, and then you go work. Yeah, just to recheck in a fast way. Okay, not in a standard way, but in a fast way, or you can just do experiments with that. Okay, let's pause. Checking before work. I think I'll use that with a straight one. I won't play with that one. Maybe I will play with this one I like. Okay, what I can find in it. I'll see. Okay, so I'll think about if this is finished with the angles, and then maybe do more or maybe not. Okay, I forgot one more thing to show. Let's put it there. Here is the block. It's similar to V1 block, but it's not that. It has a different number here and a different ISO standard. Okay, what it means is if you put them together near one another, okay, here you go. Yeah, now you cannot see that, doesn't matter. These are the same size there, but you should read the documentation of the other one if you have, because this hole is bigger. That's not 1.5 millimeters, that's I guess 3. Okay, so well, you should calibrate your machine and stuff with the one that is in the standards. But if you want to recheck after that, that's good enough, because still, if you have a 70-degree probe, yeah, that's from 30 to 60, okay, that's 70, okay, so you just put it here and find what? Okay, find what? That's interesting. You should find, no, on this block there is no such a thing. Yeah, so they are different. Okay, so you should maybe, yeah, according to this, you should, with a 70, you should, the angle is similar to here. With the 80, we have it in the probes here. The place for the 80 is here, and you still should find the hole. So maybe that's for the 80. Do we have it here? Yeah, we have it here, 80, okay. Now, the normal 70 is here, so you should check the angle with the 70 here, but you still can take this and find the hole and measure then the distance 1, 2, 3 and recheck your calibration if it's good enough. And but another thing you have to do with such a thing is, because it's different, you need to find it, the documentation then of this block and how it was manufactured, and then what is the velocity, because of that one that's 23250. With this one I have no idea. Okay, so you need to recheck, because if it's different you need to put in different number into the machine. The sound in this can go in a different speed. Okay, so but it's still good to recheck the hole, the angle, the 100 there, you still okay. And if you, yeah, maybe I'll do this in this video, because there is AutoCal, and when you don't know the velocity you do auto calibration. Okay, that's what I will do then now to recheck the velocity and the calibration with the same angle probes, but with this block. Okay, and I'll see what it shows, how much is different and how much is the same. Okay, we can work with this for like 20 minutes. Good. Now I pause and then I take all the things that I need and I return here. And that will be over with the angle probes, I think. So what I will be doing now is just rechecking like with the other version of V1 block and with a different dark blocks, and it's a good thing I have this 60, 45 with the numbers and 70. Yep, we have X value, we have a probe delay. So just I will recheck them with a different V1 block and just play around with the other blocks a little bit. Just connect now the 70-degree probe to the machine. I will be using oil and we'll check what we find. What I have done is connected the 70-degree probe. Now what I need to do is just play with this thing, and it's 25.5. Yeah, and a half. So I will put it 25.5 thickness. We are going to the big menu, and here I am putting 25.5. If we can, we should be precise. Going back. Okay, here are two legs. Our duck is like this. So I will be checking with the first leg because it's a small piece. So just like this, and we'll see later. I'll put some oil. Okay, I'll put it like this so you can see what I'm doing. I like it more. Okay, we can check near the surface, and the picture that I have drawn is, I will find it, the dimensions. Here you go, the dimensions. So I'm putting some oil on it. Just not mess up the table. Well, it's a big surface, and it's rough, so maybe not the best idea to put oil, because on a rough surface that I showed you, the round one, the transfer correction is bad with the oil, because it goes into the small parts of the metal and disappears, and well, either you have to put a lot, but then with this situation the gel works better, and this surface is also rough, so it's good enough, but you need more oil than a drop. Okay, so here I have this one, and that's 3.5 millimeters. Yeah, not centimeters. Okay, from the surface. So I will just get like 4, I guess. Okay, so I'll just here finding it out. Here it is in the beginning, and I need to move the gate there. And you can see that it doesn't go up to the black line. Okay, so you should fix that with transfer correction. Okay, so what we have here, okay, here, the highest point, let's say, is this. Yeah, I will maybe push it if it helps. Okay, here. So what we have, gel is better for this thing. Okay, that's near the end. So here is near the end. It's under, it shows under. Well, it's not under, maybe a little bit, 1 millimeter, half a millimeter, yeah, okay. Then it's 4.5. So we have the top that is 3.5. So it got the hole like in the middle somewhere. Yeah, it makes sense because the beam goes like that. And then 12 from diagonal, I won't measure it. Okay, so we found it, but it's not that high, you can see, because the metal and the surface and the oil does this job. Now I'm turned it, so now it's 13.6. I will get it from the top, so it will be 14 something in the, okay. I didn't put in the thickness. Yeah, so it should be somewhere here. This one, okay. And that is 13. Yeah, that's what we are looking at. I need to pause. I hear someone coming. I forgot a little bit what I was doing, but bear with me. So let's check this hole. Yeah. Okay, so where is the top of the spike? The highest place. Let's say it's here. So yeah, oil is not perfect. It doesn't matter. So 21. Yeah, it's good enough. 21, and then 12, 13. Okay, that's not right, because it should be, the top is 1362, or maybe not. Now it's what not. So okay, I maybe will move back 13. The top should be like 13 here, so well, is it? Yeah, it's going higher, so it's not perfect. It shows the depth 1283 and the hole is like 13 and 36. Not very nice. It goes not to 12 or 13 x value, but oh no, now yeah, now I was measuring the back wall of the hole, not the front wall. The front wall, yeah, it's 36. It's good enough. So the depth is not perfect, but the front and the angle line is good enough. So, and I can find it, yeah, here. But it doesn't reach. Yeah, then maybe I should put the gel on. Maybe it will improve. Let's try. Oil on the rough surface is not great. Let's do this. Does it improve the amplitude, the height of the graph? Let's see, this thing. Okay, now, once again, maybe not. I can't tell you what I will find here. It's still not, it reached over the second line, so it's the defect, but I think it's better connection now here. And now let's check where the highest peak is and remeasure it. Okay, here. So the defect is real, but it's not to the black line. Here you go. we haven't done transfer correction, so we don't know what transfer correction is. Okay, 22 from the nose, 13, yeah, it's still not 13, 16, and 37. Now 37 is good enough from the nose. Well, not the nose, the beginning or something. 22, 23, 22 I can see on the screen. Yeah, 22. So 2 are good, 1 is a little bit off. I'll try to get this from the back wall. So if I have put in the we have put the thickness in, so I need to find this somewhere here. Okay, let's try. Okay, no, that's the should be the corner, so it's there. I need to go back, maybe this thing here. So I will need to move the gate over it. Let's increase maybe auto 80. Where is it now? Down, and now auto 80. Here you go. So now the spike goes over the black line. That's a good sign. Now what does it show? It shows 70 from the nose. That's not the terminology I need to speak. 70. Yeah, good enough. It's 69. Now what else? 19 depth. So it goes down and up. Which one I'm taking? This one. So it goes like this and like this. So from the bottom, how? Okay, that's not good. It should be 9. It's not 19. 19 is okay. Depth from the top. So that's 14 and the hole is 3, so it's 18. The bottom of the hole is 18 and it shows 19. Yeah, it's more like 17, the bottom of the hole. And what else? That one, 88, I won't measure. So that it's in its place, this spike. So this is the 3 millimeter hole with the from the bottom. What else? Well, maybe it's enough with this thing. I want to take this thing also. And check what I can see. Okay, that's rough. And we didn't do the transfer correction. Okay, I have half an hour left to play here, because after that everyone comes back and starts walking around. So what I have done is taken this piece, okay, there is no left after 2 hours. So put some gel on it and put the thickness in. The thickness is 10. here. Now here is the hole in the middle. I don't really care where is it, up, down, but I'll just measure if I can find it from the start of the probe. So I will do like first leg, second leg, third leg, first leg, second leg, third leg, and let's find out if I can find the hole and what we can see. Not range, here, this way. Okay, so here, 3 legs. So I'm putting it 70 degree, and here it is, here, yeah? So I need the gate there. On it, and it says, well, yeah, it's under the start, okay, but the depth. Okay, so here is under the nose of the probe. Now, should I measure it under? Maybe. Well, I think it's 1, but now let's go back, and here another one here came. Yeah, you can see, and it's, yeah, in the middle. It should not be exactly in the middle, because, yeah, or maybe it should. The top side is 3, the bottom side is 4, so it's close to the middle. 3 and a hole, and 4, so it's 10. Okay, then close to the middle. It should be, this spike should be close to the middle of the leg. Okay, let's take this one. Let's move up the metal, down the metal, to check where the sound is the best. Okay, and let's take, okay, some, okay, it's good enough. Okay, now 25 from the beginning. No. Okay, now or maybe I would say that it's 20, yeah, 26. The beginning of the hole, not the middle. The middle is, yeah, 27. So 26, 25, yeah, maybe, yeah. I'm going back, but when we work with 2 legs. First leg, second leg. We don't work with a third leg just to do the experiment. Okay, I'll move the gate back over this, and here is 2 spikes, but I need 1, so let's wiggle it a bit here. Okay, the highest thing that I can get, let's increase it. Okay, here. And here, when I find it, I didn't do the transfer correction, so I don't have the amplitude correct. But here, this indication is between the registration line and the acceptance line. So if you find this, well, you should register it in the report and just say there is something, but it's not as bad as, yeah, just know. Okay, now 50 from the beginning. I can put a ruler here where it is. The edge of the ruler is the edge, no, the hole doesn't have the edge. No, it has the edge. Maybe it doesn't have the, it's like 5.2, 5 and 50 and a half. Yeah, I would say 51, 51 and a half. Okay, let's move to the fourth one. Because we still have the duck there. Okay, that's already okay. Let's take this, but and try maybe that one in the beginning. Okay, something 80. Something 80, yeah, it's 83 with my ruler, maybe 82, 80 and a half. Yeah, so you see, but if you want to mark this, you can go like 2 millimeters, not exactly here. Now let's move to the other side and do the same. I'll not do the, here is the edge of the hole, here is the probe. I'll do the second leg. Okay, now here, not to mess with the ruler. Okay, back. No, not this one. I want to put, okay. If I found something here, 26 from the start. I would say 27. Okay, going back, third leg. $51 and a half. $52 and a half. Now that was the third, the fourth. Something higher, something that would be, there is not clear. Okay, here is a clear indication, but not like this. Okay, but this is cleaner, I would say. Okay, let's try this. $79.79. It's 80. Exactly 8 what I have found here. So yeah, good enough. But I found, I think, the corner, because it's not going straight, so it's going to the some kind of edge of the side and the hole. Okay, and it reflects this spike, not like this. That's round, and that is spike in there. That's better signal, because it's the corner and edge. Let's see. Okay, so this is 70. With this thing and with the other dark block, different block, I won't use on this 60. I want to do the different V1 block. So I'm pausing and just doing auto calibration when I don't have the velocity. When I'm talking about auto calibration, I'm talking about what? We write into the system the angle, the frequency, probe number. Now cal, we find the x value with a block. We have done that. I can recheck it. Then real angle check, then cal, and if we know the velocity, we find the probe delay. If we don't have the velocity, we found both of these things together. So that's what I will go through, and I will do auto calibration on probe delay and velocity, because I don't have the velocity or sound speed in this block. I don't have the document for this one, because that's a strange one. So, but I will do that with a 70-degree angle here, and I have the data here. So angle is 70. I'll take the recall files. I will recall 70, not a duck. Let's do 74. This one, not the duck. Without duck. Enter. Unfreeze. Okay. Here we go. Now, what we have done, I have the 70 in, 4 in, and then probe number. Calibration, X value. Let's check the X value with this block. It says 13. Maybe I can do with the oil on it. That's the not rough, smooth. Okay, so what I am doing is I am putting it on 13. I am decreasing the gain, and I am checking the highest part where I can get it, and it should be where 13 is, because last time it was 13. Okay, that is good, that is good enough. Okay, here to the top. Yeah, that's 13. I am satisfied with that. Now check the real angle, and it was not okay. It was no, here was 25 and 5. 25 and 5. So okay, let's check one more. That's very small difference. It's not like 5, it's 13 or 25 and a half. Okay, here is the top. I would say it's 13 here, but still good enough. Now, real angle, 69. That's here. So I will take this, move around, put some oil, 69 somewhere here. You cannot see it, and okay, I can show you if you want, here. And then I will put it 68, 70 in the middle here. It should be somewhere. If I put it here, it's in the middle here. Okay. Oh, now you cannot see the screen. Here you go. So here, and then I think someone is already coming. What I would say here is this spike is quite strange, because here, let's say here is the spike, and I would say, well, on 70 it's like 15, so 13 is before 70. But if I go back, well, it's not going up. It's like staying at this, sometimes at the same place. So, well, like this, somehow it's not up and down, it's up and up and up and straight. So let's say this is the position, maybe the highest one here. Okay, but still here is also the same one, and in the here also the same. So okay, this is the best place maybe. Okay then, so yeah, then it is like 39 or 39 and a half. Good enough. Now what I am doing is auto calibration, and I have just put this probe on this different block, and I am checking the highest spike in here, the highest place here. Okay, once again, and then I'm checking, and it's like, let's say 14, and my X value is 12.5. Now if I put 12.5 on the line like here, Okay, what it shows is 99.60. Okay, this difference is 100, so I will leave it here, and then what I do is AutoCal, because my numbers are like this: velocity and probe delay. I'm going to here, start the gate, okay, reference 1, and record. Let's try recording. Up, left, yes, right, no, okay. Do I need another one? Okay. Wait a bit. Where is the second one? Okay, let's try. No. And the velocity is the same. It didn't record anything. Here I have made the range bigger, and here is 200 here. So now I'm going back to AutoCal, up, and ref second one. I need to move the gate start to the second one. Now the start like this. It shows 200, so the second spike is, well, 200. The one, once it goes, and the second one, it's the smaller one, it goes to 200, so it already shows what it should show, 200. But I will record the second one now. Okay, so what we have here is the data, and now we go back to check what AutoCal did. Home is down and enter, and then here. So what the AutoCal did is made 3, 2, 3, 6, and 6, 5, 7, 8. So velocity did change a bit, and the probe delay also changed a bit. Now I will just check. Okay, with these settings. Okay, with these settings, I'm moving it down, and I want to check the first one. It should be 100. This one is exactly now where it's standing, 200. This should be 100. So I'm going, not moving the probe, to move the gate back. Here you go. It's not exactly, but 100, this one, and this one 200. So, okay, that's AutoCal. And it made it so that this thing shows 100 when I'm moving it. Here. Okay, the highest spike should be 100. Yeah, and then, well, it's near 100. And then let's move here. That's 200. Okay, here. 199.76. What I can do also, not AutoCal, but with this block, is there is a 3mm hole there, so I'll take 70-degree probe with the old settings that I calibrated, duck this thing, and I'll check the 3mm hole now. Let's decrease a bit, and let's put some oil and check if I can see the defect. Okay, you can see that, okay, it went up, it went down here. So and here okay, it touches the top. So this graph is made with a duck block, and with this block the hole is the same size. So also I can move the gate back. Here you go, and then recheck if it doesn't move. Okay, when it touched the line here, it's 0, so it's at the reference line. From the beginning, 29. I can see 30 near it. Now 13, 16 depth, so yeah, on the side, because it's 15 hole, and then 45 like here to the edge. Yes, from 13 or 12 and a half x value. Yeah, so that's the hole. Okay, so you can see that on the other block I have also touched it, this line here, 0. So the defect is the same size as in the duck block, and it shows here. And no transfer correction, as you can see, because this is shiny. The metal, I think, it's also according to the standard, so it should be the same. And when I get this, okay, that's the 0, so it's on the line. So the metal, in my opinion, is the same velocity of plus minus something. The difference is very small. So you can take not the V block, but a V different one block with a different hole here, and just before work recheck on the hole the duck, your duck line, and see here that you can reach it very well. Okay, I think that's it for all the angle things, and now I need to do the straight beam things. Bye for now.